All right, we are going to talk about Module 5, Lesson 5 today. Hopefully, I do as good a job as Mr. Zazowski did with the last few. I'm going to try my best. Okay, so we're talking about inscribed angles and central angles today. So I think on Friday you should have learned that the central angle is twice as big as the inscribed angle. So we're going to use that same concept all over today. Okay, so first one says, A and C are points in the circle. Draw B so that B is the diameter. AB is the diameter. So if we extend AO across here the best we can, all right, B will be over here. Okay, so then draw angle ABC. So then this is angle ABC. All right. What angle in your diagram is the inscribed angle? That angle we just made is inscribed because it's on the circle. Vertex is on the circle, it's inscribed. Which angle is the central angle? AOC, right? The vertex is the center, so it's a central angle. Okay, what's the intercepted arc of ABC? So if we look here, up here, ABC, and we've traced that back. Let's change colors here. Maybe we'll do red here. We'll make it big. Okay, ABC is this guy. So the arc that it creates is AC. Okay, what's the intercepted arc of AOC? All right, so let's trace that one back, see what happens. If we trace that one, again, same guy. AC again. Okay. The measure of the inscribed angle of ACD is X. The measure of central angle CAB is Y. Find the measure of CAB in terms of X. Okay, so if we look here at this triangle, CAD, okay, this is a radius, this is a radius, that makes that an isosceles triangle. If that's isosceles, that means that that guy right there has to be X also, okay? So there's two ways we can think about this. All right, we can use what we did Friday and said that that has to be double. Or if you think way back to maybe September, October, these two angles here and here add up to this guy out here. So Y would equal 2X. Okay. A and C are points on circle O. What is the intercepted arc of AOC? AOC creates this arc. That is AC. Draw triangle AOC. Let's change to blue here. Here's triangle AOC. What type of triangle is it? Doesn't look like it because I did a bad drawing, but it's an isosceles triangle. Make sure I spell this right here. Okay, the radius are the same. We don't know about that line AC, so we can't say it's equilateral, but we definitely know who are the same. Okay, so what can we say about AOC and ACA and OCA and OAC? They are congruent because, let's say, what do we want to say here? We want to say angles opposite congruent sides are congruent. Okay. Draw point B on the circle so that O is on the interior of the inscribed angle. So we'll put B right over here. So that way if we draw this angle, O is inside that angle. Okay. What's the intercepted arc? Color it green. All right. Here we are. Okay. So it's AC. So what do we notice? Okay. AC is the arc for both angles. Okay. Ooh, too far. Okay, if the measure of ABC is x, no, I think we're going to skip these ones. All right, we're going to skip these because we don't need to prove this. We did it on Friday. Okay, this is kind of similar. Draw B so that O is an exterior of the inscribed angle. So if we put B down here now, here's our angle. Okay, what's the intercepted arc? Okay, again, it's AC, right? So again, this is double. Okay, and we're gonna skip. We're gonna skip ahead here. Do some math now. All right. So what do we want to know? What do we need to know? So let's just make a quick conclusion over here. So we have three scenarios that we should have seen today. All right. We have our central angle. And we have our inscribed angle. Could look like that. Could look like that. Or it could look like this, right? Okay. Either way, this angle here, the red angle, is going to be half of the green angle, the central angle. Okay? The red angle, the inscribed angle, is half of the central angle. So that's what we're going to use for all of these questions, right? So if D down here is 25, we double that, X has to be 50. If D up here is 15, well, we know this is isosceles, so I'm sorry, this is 15. That makes that one 15. Okay. This diagram is labeled wrong. X should be up here. Okay. So this is a 90-degree angle. If you follow both of those angles out, they both make arc BC. Okay? All right, so this angle here makes arc BC. This angle here makes arc BC. This is an inscribed angle. This is a central angle. So X has to be half of that. X is 45. Okay. Next page. Angle B is 32. So that's 32. Which means that angle A has to be 64. Okay. So now I know again that this is isosceles. So that is also X right there. All right, so we could say 64 plus X has to be 180. 64 plus 2X is 180. And then subtract 64. So 2X is 116. And X is 58. So there's how you do that one. Okay, AB is equal to BD. All right, AB is also equal to AD because they're both radius of the same circle. That means that's an equilateral triangle, so X is going to be 60. Okay, D down here is 19. Okay, so this is just like question D. So if you want to pause it and try it on your own, go for it. If not, we'll just do this. So if that's 19, this central angle, again, they make the same arc. So that makes that 38 in there. Okay, so this is an isosceles triangle here. Right here is our isosceles triangle. So we could say 38 plus x plus x is 180. That's also x again up there. So 38 plus 2x equals 180. 2x equals 142. So x is 71. Okay. Next one. Toby says that angle BEA, this one right here, BEA is 90 degrees. Okay. Is he correct? Justify our answer. All right. So to figure out what BEA is, I'm actually going to figure out what BEC is. Okay, we're going to use this blue triangle to figure out what that one is. This up here was 50. Let's not forget that. Okay, so if this is 70, makes this arc up here, right? Same arc as down here as this angle. Same arc as this angle here. So that makes this guy 35. It's half, or yeah, half of 70. Okay, so if I add 35 plus 50, I get 85. 180 minus 85 is 95. That means this angle right in here is 95. And these are vertical angles. That means angle BEA is 95 because vertical angles are congruent. So don't be wrong. Okay. This one. All right. There's another rule here that we're going to write down. We probably talked about it, maybe talked about it on Friday. So, okay. Opposite angles of an inscribed quadrilateral add to 180. Okay, so inscribed means all of the angles are on the circle. So that means opposite angles. This guy would add to 180. This guy and this guy add to 180. Okay, so we could say x plus y equals 180. So if I wanted to do x in terms of y, I would say x is 180 minus y. I don't do y in terms of x, I would say 180 minus x. Okay, so they add to 180. Okay, how many angles have the same measure, and what are their measures in terms of x? There's lots of angles that have the same measure in this diagram. So we're just going to do the inscribed angles that have the same measure. Okay, so this inscribed angle, B, this inscribed angle, E, this inscribed angle, F, all create the same arc. They all make DC if you follow them out. You follow this guy out, and you follow this guy out, and you follow this guy out, they all end up at DC, so they're all equal. So angle B is congruent to angle E, which is congruent to angle F, and they all equal X. Okay. The other ones that are congruent are Y and this one, because they all make this arc right here. So, in terms of X, so these are all quadrilaterals. Let's just draw one in here. Here's one inscribed quadrilateral, right? So if this is X, then this has to be 180 minus X. Okay, so angle, what's that angle? Angle H is congruent to angle G, and they're both equal to 180 minus X. Okay, we're going to find the measured angles here. Find all the ones that are labeled. All right, so we know that those are, that's 28, that's 74. What is X and Y? All right, so if I look and I follow this out, that angle 28 makes BF. That means this angle down here has to be the same as that because they also make BF. So that's 28. And they're both X, so that's 28. So X is 28. All right, then I have this big triangle here. Okay, I know that's 74. If I put these two together, I get 56. 74 plus 56 is 130. And then 180 minus 130 is 50. So that's what Y is. Okay, B, we're not doing. We don't have the rule yet to do B, so that question we can't do till a later time. Okay, so next one, we got to find X. Okay, there's two ways to do this, but this is BC, right? This angle down here is 40, it makes BC. This central angle also makes BC. And I know the central angle is double the inscribed, so that angle down there is 80. Okay. So there's two ways we can do this now. We can find this angle right here, down here. Okay. 120 minus 180. Add the 80, subtract, and get X. Or again, we can use that remote angle theorem that we were talking about. So 80, that we mentioned in the beginning of this video, 80 plus X has to equal 112. So I'm going to do that. Save myself a little time. So X is 32. Okay. This one here, we have this angle and this angle, right? That angle there, this angle here. This one's 120. That angle has to be half, so it's 60. Okay. And then if we keep looking at this, we'll go back to green. This is an inscribed quadrilateral. So if this angle up here is 60, that one has to be 120 because they have to add to 180. All right. I know that angle is equal to that angle. That means this angle equals this angle. Our side, those sides, I'm sorry, are all equal. So we have a rhombus. So if these are both 120, these have to both be 60. Okay. So again, now I got to use this inscribed triangle. This angle is 84. 84. This whole angle here is 84. So 180 minus 84 is 96. So that whole angle opposite, this whole angle over here, 96. Part of it's 60. So we subtract, we get 36. Okay. Last two we're going to do today. Okay. This angle is 60. This angle makes the same arc, which makes that 30. And we got this triangle here. And we got this triangle here. Okay, this is isosceles, right? And the angle between there is 60. So that means this is an equilateral triangle. So that's 60. That's 60. Okay. So if I add these up, I get 110. And then 110 plus 30 is 140. 180 minus 140 is 40. So that's what x is, 40. And then the last one here, we got this angle. That makes BC is 60. We got this angle. That makes BC has to be half because it's inscribed. That's 30. All right, we're going to stop there for today. There's a whole bunch left in the problem set. If you want to practice them on your own, try to get look the answers up. Okay, so what do we know from today? Inscribed angle is half the arc. Central angle equals the arc. We have an inscribed quadrilateral. The opposite angles add to 180. All right, so there's a near pod to do after this, and there's all these questions in the problem set if you want to practice more.